अस्सलामुअलैकुम आज हमने जिस अस्सलामुअलैकुम टुडे द टॉपिक ऑफ आवर डिस्कशन इज the extrema for the function of two or more variable. We have a function, let we have a function of f which is a function of variable x, y and z. How can we find the extrema of that particular function? There is a hessian matrix method which says that for finding the extrema, first of all we have to find the first order partial derivative, like partial derivative of f with respect to x, similarly the partial derivative of f with respect to y, and the partial derivative of f with respect to z. After finding these partial derivative, we put all these derivative like fx, which is the partial derivative of f at x equal to 0, and partial derivative of fy equal to 0, and partial derivative of fz is equal to 0. We got three equations: equation 1, equation 2, and similarly equation 3. We solve these three equations and find a critical point by solving these equations. The point is like a x naught, y naught, z naught, which is our critical point. At this critical point, we check the function is have relative minimum or relative maximum. So in this question, we have this function which is f of x, y, z is equal to 1 over x plus x over y plus y over z plus z. We have to, first of all, in order to find the extrema, first of all, we find its partial derivative with respect to x as well as with respect to y and z. So, what is the partial derivative of this function with respect to x? It looks like this. Partial f by partial x is equal to the derivative of 1 over x. Actually, we can write 1 over x in the form of x minus 1. So, when we apply the power rule, it becomes like this: minus 1 comes first, then x raised to power minus 1, and the derivative of this function, which is x, which is 1. So we get minus 1 x raised to power minus 2. We get minus 1 over x squared. This is the partial derivative of f with respect to x for this term. So it will give you minus 1 over x squared. Similarly, here we have x, the derivative of x is 1, and this is 1 over y is stating as the constant, so it comes as same. So this is the constant, and similarly this is constant. The derivative of y over z and z is 0 because we are taking the partial derivative with respect to x by treating y and z are constant. So this is our partial derivative with respect to x, which we can denote it by fx equal to minus 1 over x square plus 1 over y. In the similar way, we can find the partial derivative with respect to y. Uh, we have to find its derivative with respect to y. So partial f by partial y is equal to the derivative of this 1 over x is 0 because we are taking y as variable and x and y are constant. So that's why this first term derivative is 0 plus the derivative of this term. This is x. It's comes same like is, and here is y raised to power minus 1, which is 1 over y. We apply here the product rule. Product rule says that minus 1 comes first and then y raised to power minus 2. We can write it in the form of minus 1 over y square. So this is the derivative of 1 over y. So 1 over y derivative is actually minus 1 over y square, and here it is y. Its derivative is 1, and similarly z same as it is, plus the derivative of this c is 0 because we are taking the derivative with respect to y. So treating x and z are constant. So we get x minus x over y square plus 1 over z. This is our partial derivative with respect to y. In the similar way, we find the partial derivative with respect to z. You can see on your screen. This is the partial derivative with respect to x, and similarly, this is the partial derivative with respect to y, and this is the partial derivative with respect to z. After finding these three derivative, we have to put these three derivatives equal to 0. So it will looks like it becomes 0. If it's becomes 0 and gives you minus 1 over x square plus 1 over y equal to 0, this is our first equation. And in the similar way, this is equal to 0, it will give you x over y square minus x over y square plus 1 over z is equal to 0. And similarly, we get minus y over z square is plus 1 is equal to 0. We got three equations. You are looking on your screen as well. This is your first equation, this is your second equation, this is your third equation. We solve these three equations and find the values of x, y, and z. So first of all, I am taking this first equation. This first equation actually what? It's minus 1 over x square is equal plus 1 over y is equal to 0. It will give you 1 over y is equal to 1 over x square. If I change the fraction, I will got x square is equal to y. So y is equal to x square. Actually, this is the value that we have obtained from the equation 1. In the similar way, we have find the value of y from the equation 1. We have find the value of y from this equation, which is x square. We put this value into this equation, we get minus x, and this y replaced with this value x square, its square plus 1 over z equal to 0. It will give you x over x raised to power 4 plus 1 over z is equal to 0, and it will give you minus 1 over x raised to power 3 plus 1 over z is equal to 0. From this equation, we got 1 over z is equal to 1 over x raised to power 3, and from this we get z is equal to x raised to power 3. This is our equation. We have obtained y is equal to x square and z is equal to x cube from the first and second equation. So after solving the first two equations, we get the values. Now we put the value of uh, given equation into the equation number 3, which is like this. We have minus y over z square plus 1 is equal to 0. We solve this equation. How can we solve this equation? We have this equation, we can solve it by, if I take this side into this, I will get 1 is equal to y over z square. From this, I will get y is equal to z square. So this is the value of y that I have find. And as I have solved earlier, I have got y is equal to x square and z is equal to x raised to power 3. And the third value is y is equal to z square. So when you are looking on your screen, these two are same. Like here, the left hand side is y and left hand side is y. If two equations have same one side, then the other sides must be equal. So x square is equal to z square. From this, we get x is equal to z. From this, we will get uh, x cube is equal to x square. Y it's x square. We get z is equal to square root y. So we have find z, which is equal to x cube, and here is square root x square, and we get x is equal to square root x cube. So from this equation, we get only x is equal to 1. So this is the value of x. After getting the value of x, we put this value into equation y. Actually, y is equal to x square. We put value here. 1 square, it will give you 1. So y is 1. In the similar pattern, we use this value z is equal to x raised to power 3. It is equal to 1. Z is equal to 1 raised to power 3. It will equal to 1. So z is equal to 1. We get the point 111. This is our critical point that we have find. So our critical point is this one. Critical point is like this one, 111. I have teach you the second derivative test, which is for the function of two variables, in which we have discussed like this thing, d is equal to like the determinant of fxx, then fxy, and then fyx, and then there is fyy. And we say that if d greater than 0 and this element a greater than 0, then the function is local minimum. And if d greater than 0 and a less than 0, we say that the function has local maximum. So in the similar pattern, we have the for the third order matrix, or for the function of three variables like x, y, z, we have this matrix. Like we have it is in the form of like a hessian matrix, like in this form. Like if we are here, we have fxx, then fxy, then fxz, this thing. Then we have fyx, then we have fyy, and then we have fyz. In the similar way, we have fzx, fzy, fzz. So we have got these this matrix. It's fxx, fxy, xz, fxz, fyx, fyy, fyz, fzx, fzy, fzz. We got this matrix. Now our target is to find these values: fxx, fxy, fxz, fyx, fyy, fyz, fzx, fzy, fzz. As you are looking on your screen, we have find the fxx, which is this one. I I know you know very well how to find the derivative and partial derivative of a function with respect to x, y, and z. How can you find the mixed derivative like fxy, fyz? So this is fxx, this is fyy, and this is fzz. It's fxy, and similarly it's fyz and fzx. So we got these values. And remember one thing: fxy is equal to fyx. If you got one value, then the other value is the same. So your duty is to just find one value. After that, you can also find fyz is equal to fzy, and similar in the similar pattern, fxz is equal to fzx. Just find three values, only three: fxy, fyz, and fxz. After that, the result that you have obtained, like fxx, fyy, fzz, fxy, fyz, fzx, you have to put the critical point, which we have find, which is 1, 1, and 1. You have to put 1, 1 in this equation, like it looks like a partial square f by partial x square. You find its derivative at the point 1, 1, which is 2 over x3. Here the value of x is 1, so it's 1 cube. It will give you 2 over 1. It will give you 2. In the similar way, you have to find the fyy, uh, partial square f by partial y square at the point 1, 1, 1. It will be equal to 2 into the value of x is this one, 1, and divided by the value of y, it's 3, y is 1, it's 1 raised to power 3, it will give you 2. And in the similar way, you have find the values of this function at 1 at this point, and this function at this point, of this derivative at this point, and similarly this derivative at this point, and this derivative at this point, and this derivative at this point. You got this matrix. After getting this matrix H, which is known as the Hessian matrix, you have to take its determinant. You find its determinant. This is your matrix. You can take its determinant like this. H determinant is equal to 2 minus 1 0, and it's minus 1 2 minus 1 0 minus 1 2. Its determinant 2. You have to ignore the first row and first column. You get 1 2 minus 1 2, and then you have to put minus sign, and this number is minus 1. You have to put the straight lines. You have to ignore the first row and second column. You got minus 1 and 0 2, and then you have to put 0 and this number, which is minus 1 2 0 and minus 1. You got 2. This is actually 4 minus, it's minus 1, and then this is plus 1, and it will give you minus 2 minus 0, and this is a 0. You got 2 into 3 plus 1 into minus 2, and then here is 0. You got 6 minus 2, which is 4. So when you find the determinant, you got the value like this one, 2, which is greater than 0. So your value, the your determinant value, which you have find the determinant of H, which is this one, 6, which is positive. This is your Hessian matrix. And in the similar pattern, you have to check this number. This number is actually is it's look like the it's is delta 1. Delta 1 is actually this first element. Then delta 1 is 2, and delta 2 is actually the determinant of this matrix, this, which is a 2 minus 1 minus 1 2. It will give you 2 multiplied with 2, 4, then minus, it's minus minus become plus 1, it's 4 minus 1 gives you 3. So this is delta 1 as well as delta 2 you have find, and in the similar pattern you have find the delta 3. And you know all the deltas like delta 1, delta 2, delta 3 are positive. It means that your matrix is positive definite. It's looks like the same that I have teach you in the linear algebra course, the quadratic form, and it's a canonical expression. It looks like the same. You find delta naught, delta 1, delta 2, delta 1, delta 2, and delta 3. If your Hessian matrix A, so when is your value is minimum? Minimum means that your if the value of delta 1 greater than 0 and the value of h greater than 0, then your matrix has local minimum values. Or delta 1, delta 2, if your all deltas are positive, then your function has local minimum value at that point. If you have all the deltas are negative, then you say that it has local maximum at this point. If you got the delta, like if one delta is positive and an other is negative, which is the mixture of positive and negative, which means that it's neither increasing nor decreasing, or you say that this point is a saddle point. So this is our topic. I have teach you how can you find the extrema of the function of three variable. Before this, I have teach you how can you find the extrema of the function of two variable. And you look here, I have teach you the question 10 first part. It's your duty to do question 10 second part. I hope that you will understand this topic.